Hello, hello, hello. This is Mrs. Slater, ready for 11.6 notes and graphing. So the first one that I want to look at is already done for you, but just to take a few notes on it. You can see that we have a polynomial that is a quadratic, so you're going to have a U shape. And notice that the ends are going up on the left side and the right side. So we're going to have a summary at the end, and I kind of want you to just take notes along the way. And you can see a degree of 2, so that's nothing new because that right there is the 2. And then the left and right, what that means is left end behavior. So we are going to refer to this going up on the left side. And so it's a plus sign, or you can just say up. And then on the right side would be the right end behavior. And you can also say that it's just going up. The number of real roots, you can see that it goes through in 2 places. So right here and right here, you've got those 2 intersections. Let me just go make a dot there and a dot there. And then the number of humps, 1 hump is this part right here. So 1 hump, and that's where we're going to get all the information. But in that little box, I want you to put how you can find those. The maximum number of humps that you can have is 1 less than the degree. Okay, so keep that in mind when you're trying to do the humps, and that'll give you a good idea of what your graph is going to look like. Okay, and then as far as how to find the real roots, in this case it's a quadratic. So the quadratic formula is your friend for this one if you want to find out what those 2 values are. That one is a negative 1.2, and then that is 1.2 if you did the quadratic formula. Okay, let's go ahead and go on to the next one. I apologize for the graphing. I did a lot of cut and pasting here. And first of all, we have another quadratic because the degree is 2, so you can go ahead and put that in there. The left and right end behavior you can find by just plotting the point. This is already in vertex form. So if you recall, there's no value there and there's no value here. So I can go ahead and graph the origin at 0, 0, 0. I'm going to change to red. And then because it's 1/2, it's going to go over, it's going to be upside down, and it's going to go in a wider shape. So we're going to go ahead and make that just a little sketch of what it looks like. You can test this on your y equals formula calculator if you'd like as well. Okay, so what ends up happening to the left side? Well, it's going down. So that's the left end behavior, and then this side is also going down. So keep that in mind when we are doing a summary of why that happens on certain problems. The number of real roots, you can see there's only 1 time that it goes through the x-axis, and the number of humps is going to be 1. Very good. So let's go on to the next one. The third one is a little trickier, so you can go ahead and push pause and get some nice points to graph. Actually, I'll go ahead and do this one with you. So in your y equals, we're going to go ahead and put 3x to the third and minus 5x and then minus 1. Let's go ahead and check the graph out. And we're going to transfer that picture onto our graph on our paper. So let's go ahead and go to table and get a few nice points. Already I see that 0, negative 1 is a great point to plot. And I'm going to slide this over because I can't get both. So you have 1, 0, 1, negative 3, and another one that would fit. And I got to go back to the graph. Let's go up a little bit and we can get another one. There you go. So negative 1, 1 is the last one that I'm going to put on my graph, 1. So it looks something like that. The 3 nice points. And then to get the curve that goes with it, I'm not really picky at this point, so you know it kind of goes like this and back up again. Okay, notice what the end behaviors are, because that's what this lesson is truly about, is what's happening on the left side? Well, it's going down. What's happening on the right side? It's going to go up. So the degree is 3, and then it went down on the left side, and on the right side it went up. The number of roots, you can see that it goes through, and I'll put them in purple. It went like 1, 2, 3 times this time, and that makes sense because the degree is 3, and that's the highest number that you could have. The number of bumps, here's 1, here's 2, And like I said before, the maximum number you can have is 1 less than the degree. So it all makes sense there. Okay, let's go on to the next one. Oh, and by the way, before we go on, the number of real roots, since it's not a quadratic, you're going to have to use the rational root theorem to find them. Rational roots, and then have your calculator help you as well to find roots. Okay, and that'll help you find out what these are right here and here and here. Okay, number 4 is a cubic a function as well, cubic meaning 3, so that's our degree. Left and right in behavior, so go ahead and go to your calculator, and I want you to go ahead and punch it in, and then push pause and I'll come. So under the table you should have found 3 really nice points that are going to fit on our graph. -1, 1, 0, 2, and 1, 3. And with the sketch of it, you can see it kind of starts up here and hits those 3 points and then comes straight back down. Okay, so that's again, this is not, doesn't have to be exact right now, just getting a good idea of it. All right, so then after that we can answer some more questions. On the left side, it's going to go up. On the right side, it's heading down toward the negative numbers, so I'm going to go ahead and push down. Number of real roots, look at that, it only goes through 1 time. Number of humps, there are 1, there's 1 here and 2 right here, so we'd say 2 humps for that one. Okay, and again, ask yourself how you're going to find the actual root that's right here. It doesn't factor nicely because it's not a quadratic, so you're going to have to use the rational root theorem and a little bit of calculator help to try to figure out what those roots are. Okay, so let's go ahead and go to the next one, which is a polynomial of degree 4. So we can go and write that down. Go ahead and push pause and get the graph. Okay, so if you are not getting the same table as I do, then go ahead and recheck your work. If you do, you can go ahead and plot those points. And it looks like a really nice one is at -1, -4. So I'm going to put a point there. 0, -6, and also at 1, 2. And then if we're going to get an example of what that looks like, let's go back to our table or our graph. It kind of looks like a parabola, but it can't be, so I don't want to make it look like a parabola necessarily. This right here is the y-intercept, and I can't really point to it because I think, oh yeah, I can. Okay, so that's the y-intercept, so it can't really, it has to go a little farther below that, so that's what I'm going to try to make an example of. It also says at -2, 20, so that's way, way, way up there. So coming like this, goes a little lower, and then back up again. Again, we're just in sketching mode right now. I know that doesn't just give it, doesn't justify it. So left in behavior, that's going up, and this one's going up, so then we would put both up for left and right in behavior. Number of real roots, how many times does it go through? There's 1, so it's going to be 2. And then the number of humps, we're only going to have 1 hump. So this is the first time it was not exactly 1 less. It doesn't have to be 3. All the time, but it has to be at least 1 less. So it could be 3, it could be 2, it could be 1. And then how are you going to find what those values are is the rational root theorem. And that's going to help you find out what the x-intercepts are. All right, and then the last one is also with a degree of 4. So I'm going to put that in there like so. And then go ahead and push pause and put it in your graph, and then we'll compare our answers. Okay, so after you graph it, you should have the same table. If not, go back and check your work. And let's go ahead and plot some of these points. You're at -1, 0, which is here, and then 1, 0, 4, 0, and then I believe there's another one if I scrolled up at -4, 0. Yeah. Okay, so then you got a lot of things going on here. Now most of you will just look at that and then finish it, pick it up where it left off, and because you don't see that on your graph. Okay, so that's all you're seeing is a bunch of lines. So I just want to fill in the blanks a little bit because I don't think that really truly represents what the graph is actually doing, and we can't really tell what the end behaviors are because they're all over the place. So if you would go to 0, 16, I think that would help. And I know your graph has a little more than that, so it's going to go all the way up here and then start heading back down. So all the way to 16. That's supposed to be 16. And then here at 2, -36, so you're all the way down to -36. So keep that in mind that it's going to go all the way down, it's going to loop, and it's going to go right back up again. And then same thing for the other side. It's going to have this extra loop attached to it. And then these are going to continue to go on forever. Check your table. You'll see that if you plug in a 4, a 5, or a 6, it's going to go way, way, way big numbers. And yeah, I just want to emphasize that. So it's like a really skinny W. Left end behavior is going up. Right end behavior is going up. Number of roots, you can see that it's 4 times on that one, and it makes sense because their degree is 4, so those have to be the same or smaller. Number of humps, again, I wanted to draw that so you can get the humps. So here's 1, here's 2, and then here's the third one up here. So there's 3 humps total for that part. And then it comes, and the last thing I want to tell you is, well, how do you find the roots for something like this? Before, we've had factoring, we've had quadratic formula, and then we've had the rational root theorem. This one, as I've always tried to emphasize, you can factor, or if factoring is possible, you should always want to factor. And you can see that after you factor this, x minus 4, x plus 4, x minus 1, and x plus 1, we've got a match with all of our x values. So all of the roots end up matching what you have. So factoring definitely is the fastest way to find all of your roots. Okay, that concludes the notes. So toodaloo. So if you're still listening, I have one more thing to tell you. And I told you at the beginning I'd make a summary of everything. So you may have noticed this already, that at the for the end behaviors, and you can put this on your notes somewhere on the side here, it's called the end behavior chart, where if you had an even degree, did you notice that the left and right sides always went up? And then if you had a leading coefficient of plus, that's when you have both sides going up. But if the leading coefficient was negative, then they were both going down. And then for an odd degree, what ended up happening is they were both going in opposite directions. So the right side was going up, and then the left side and the right side would go down if it was negative. So for example, if you had y equals a negative x cubed plus x squared plus 1. If you want to know what the graph is going to look like, the negative means that the right side is going to go down. So some on the right side is going to go down. And then because it's odd, it's going to go in opposite directions. And then something that I don't have with me right now does something funky in the middle. Okay, so that would be what the end behavior is. And then just to practice one more, if you had x to the 6th plus x to the 4th plus 7, then based off of the summary, you can get the end behaviors. So it's an even degree, which is 6. So it's even degree, and it is a positive coefficient. So there's a plus sign here, even though it doesn't have it. So that means that it's an even degree. It's going to be left is up, right is up. And then, you know, we got humps and bumps in between there. But knowing that they're both going up gives you a good idea of what the graph is all about. And then I'll just do one more. Y equals, let's go with a negative x squared plus 2. Okay, it is a negative, it's a even degree. So we're in this category again, this category. And then we also have a negative in front. So you have to go to this side. So the blue one would be left is going to go down and the right is going to go down. And because it's a quadratic, all the stuff you fill in would be something like that. So hopefully we were able to listen to that part. Sorry, I didn't mean to say ta-ta there at the beginning. And again, well, I'll talk to you later. Bye.